With FieldLink 6.9, we now have improved inspection analysis features. Here you can see where this scanner was tied into control with a resection and these paddleboard targets. That took about 5 minutes and hopefully would be less than a 16th of an inch. We then collect 6 other scans in about 2 minutes. Those were all automatically registered together. I would refine them, and then that refine accuracy plus my setup and the range accuracy of the scanner, which is about 1.5 millimeters for the X9 scanner, would determine my overall accuracy. But generally, we would hope to keep that well less than 1/8 of an inch. But there are some contributing factors to think about there. But it is, again, much easier to make that comparison, especially a relative comparison, like in this example, just checking the camber of the steel. So I am obviously in the office, but to record this, but to run this in the field, I would go through the same setup like I would with a total station, and then move the scanner around to take those scans throughout. And then as long as I have that model, I can run the inspection on everything within this section box I just turned on, or I can manually click using this button down here, the components I care about, or just turn off those layers I don't care about. And so what you can see here is that is a very quick way to start to look at the camber of all those beams very quickly. I can bring this down to a tighter tolerance, so it will hopefully highlight what's in and out a little bit better. So most of it's well within 1/4 of an inch. For steel, there's not much I'm going to change there. I would like to go back and scan after the concrete's poured if I wasn't sure about the camber, but right here we can see that's pretty good. I could even send individual points if needed as an analysis. That'd be similar to going up with a total station, actually measuring or shooting with a DR measurement to the bottom side of that. But this is, again, going to be much faster and actually capture everything else out on site. If I was a general contractor, I could use the same thing to actually compare back to like the sleeves and a pour to check that as well too very quickly and actually make those changes in the field. For steel, because I'm probably not going to roll out new iron or be able to weld anything differently, I'm probably going to live with what's there. And then with this inspection cloud, what I'm able to do is not only see the positive negative of where things are at, so that's the first big improvement, but I can export that out as an E57 and bring that or share that with my coordination team and bring it into any BIM, CAD or BIM program, a coordination program, as well as cloud sharing platforms. So here you can see it in Tekla, where then I could use this as the point cloud as my as-built, or I could update the model or share it with other subcontractors coming later so that they can route around what is different than what was originally designed. And so hopefully, if the steel's out, the edge of concrete's a little bit different, everyone else can see that and then readjust their plans of what they're doing on their fabricated work. So you can, again, as always, use scanning for renovation and retrofits to capture the as-built of a facility and then just design in what you're going to build. But you can also use it throughout the phases of construction to confirm what's being put in is what was designed, and if it's different, hopefully update that. Please reach out to your nearest building point representative if you have any questions or would like to see a demo. Thanks.